This picture shows the basic ER diagram notations. We have a number of different notations for entity types. The first one, the strong entity, which is the most common type of entity. And then there is also a weak entity. You use double lines. A weak entity is an entity whose existence depends on the existence of another entity. So for example, you have a strong entity called employee. You will use a rectangular shape to represent that employee entity type. And then employees probably have dependents. So the dependent of the employee is a weak entity. The reason is because the instances of the dependent entity type really depends on the instance of the employee entity type. So without the instance in the employee entity type, you wouldn't have any instance for the dependent entity type. So that's why this is a weak entity. And then there is something called associative entity. And the associative entity is actually a relationship that was transformed to become an entity. Associative entity, it's a rectangular shape with rounded corners. We also have a number of notations for attributes. The first type of attribute here is an identifier. Identifier is also referred to as a primary key. It's something that will uniquely identify each and every record in an entity type. For example, each customer has a unique customer ID, each student has a unique student ID. The customer ID or student ID would be the identifier. To show that this attribute is an identifier, you will use an underline. Partial identifier, usually the identifier for a weak entity. For example, for the dependent entity, if the dependent has a primary key, so you use double line for the identifier. You can have optional attributes, which means, well, these attributes may not have a value. For example, cell phone number. So somebody may not have a cell phone, so you may not have a value in that attribute. You can also have derived attributes, which means the value for this attribute is not stored, but calculated during runtime. For example, age. Age would be an example of a derived attribute, right? Because you do not go into the system and update somebody's age every year. What you do is you ask the system to calculate the age by subtracting the date of birth of the person from today's date. To show that, you use the bracket. And the multi-valued attribute. Sometimes for the attribute, you may have multiple values. For example, skills. The employee may have a number of skills. So there may be multiple values for this attribute. Then this is called a multi-valued attribute. And then there are also what's called a composite attribute. For example, address. For the address attribute, you may have a street address, city, state, and also zip code components within the address attribute. So address can be a composite attribute. So what you do is you put them in parentheses and separate them. There are some notations for different types of relationships. Here we have 3 different types of relationships. Actually 3 degrees of relationships. Well, the relationship degree refers to the number of entity types involved in the relationship. So for example, this unary relationship only has 1 entity type involved. The binary relationship, which is the most common type of relationship, has 2 entity types involved. And the ternary has 3 entity types involved. And then there are notations for relationship cardinalities, as we already saw in the previous slide. So the first question you need to ask yourself before you draw the ER diagram is what should be an entity and what shouldn't be an entity. So here there are some guidelines about what should be included as an entity and what shouldn't be included as an entity. An entity is an object that will have many instances in the database. So for example, student or employee, because you can have many instances of students and many instances of employees. An object that will be composed of multiple attributes. If this entity has multiple attributes, like employee has employee ID, first name, last name, address, and so on, to describe this entity type, then it meets the criteria, right? And also, the entity needs to be an object that we are trying to model, which means it's something that we are interested in, something that we want to include in our database. Then you need to ask yourself what should not be an entity type. If the object is a user of the database system, then it shouldn't be modeled as an entity type. Or if the object is an output of the database system, for example, a report, then it shouldn't be included in the ER diagram either. So let's look at an example that will illustrate what we are talking about here. In this slide, we have two ER diagrams. The picture at the top is an example of inappropriate ER diagram. But if you read this ER diagram, it says, well, the treasurer will receive expense report. And the expense report summarizes the expense, and the expense is charged to the account, and the treasurer will manage the account. It seems like it makes sense. However, the problem here is, well, the treasurer is really the user of the database. So we are not really interested in collecting information about the treasurer. And then also for the expense report, that's really an output of the database. The expense report basically has a collection of the expense and accounts. So it's really an output. It's again not something that we want to keep in the database. The appropriate way to model this database would be like in the picture at the bottom here. You only have two entity types. One is account, the other is expense, and the expenses are charged to accounts. Before we look at some examples, let's talk about identifier, primary key. Primary key is probably the most important attribute in a table or for an entity type. So it's an attribute or a combination of attributes. Sometimes you may have multiple fields together as the primary key that uniquely identifies individual instances of an entity type. So that's what an identifier or primary key is. You can have simple identifier or composite identifier. For example, employee ID would be an example of a simple identifier because there is only one attribute. But sometimes, like example for flight information, you may need multiple attributes to be the identifier because one attribute is not unique enough. For flight entity type, identifier would be flight ID, and the flight ID consists of two fields. One is flight number, the other is date, because the flight 8810 will appear every day. And only when you put the flight number and the date together, then this field or this combination of the two fields will be unique enough for each instance of this entity type. So this is an example of a composite identifier. There is also a related concept called a candidate identifier. Candidate identifier is an attribute that could be a key. It satisfies the requirements for being an identifier. However, it may not be the best identifier. Like for example, let's say you have a table, employee table, and within the employee table you have a number of attributes. You have employee ID, last name, first name, street address, city, state, zip, date of birth. So within this table or entity type, well, there are a number of candidate identifiers. For example, employee ID is a candidate identifier because it can uniquely identify each instance of the entity type. Is last name a candidate identifier? Probably not, because you may have employees who have the same last name. But what about last name and the first name together? Would that be a candidate identifier? Well, again, it may not be the best identifier because, well, some people may have same last name and same first name. But what if you add the date of birth to the combination here? So now you have last name, first name, and date of birth together. Is that a good candidate identifier? Well, maybe that's unique enough. You probably wouldn't have two people who work for the same company, have the same first name, last name, who were born on the same day. I mean, the chance of that is pretty slim. So that these three fields together can also be a candidate identifier. However, it may not be the best identifier because employee ID seems to be a lot simpler than having these three fields together as the composite identifier. How do you select a primary key or identifier? Again, there are a number of guidelines. The first guideline here is the identifier should not change in value. So for example, if you use phone number as identifier, well, it's probably unique enough, right? Everybody has a different cell phone number. However, the problem with that is that phone number probably will change pretty frequently. So that's why the cell phone number, it would not be a very good identifier. It will not be null, which means it wouldn't have null value. So for example, a cell phone number, again, it wouldn't be a good identifier because some people may not have a cell phone, can have null value in that field. For identifier, you have to have a value in it. You shouldn't use intelligent identifier, which means the identifier that contains locations or people that might change. For example, if your identifier looks like this, W05LA, well, maybe this is referring to a location like Los Angeles. Maybe this is referring to district in Los Angeles. This wouldn't be a good identifier because some of these locations and the names of these locations may change in the future. This is called intelligent identifier, so it wouldn't be a good identifier. And then the last guideline is to substitute new simple keys for long composite keys. So that's the reason why we want to use employee ID as the identifier instead of using the combination of first name, last name, and date of birth, because employee ID is a lot simpler than the composite identifier. These are some of the guidelines you can use for choosing the identifier for the table or the entity. In this slide, we have an example of a composite attribute, employee address. For employee address, we have the street address, city, state, and the postal code. You put these simpler attributes within the parentheses. Here is an example of a multi-valued attribute, skills. Here there is an example of a derived attribute, years employed. For this field, we are not going to store a value in the database. We are going to calculate this when we use this field. So that's why it's called a derived attribute. This is an example of an attribute that's both a multi-valued attribute and a composite attribute. In this example, we have a situation called a time-dependent attribute using a technique called time stamping. Well, this is actually a pretty common situation in business. The product may have a price history. For a different date, price may be different. In order to capture that piece of information, we need to create an attribute called a price history, which is a multi-valued attribute because we have many effective date and the price combination in the price history. At the same time, price history is a composite attribute because it has a date and also a price associated with that date. So this is a situation called a time-dependent attribute, and we use time stamping to model that.